To cut the sheet metal pieces, first take the measurement with the compass and transfer it to the tin plate. Also use the compass to draw parallel lines on the sheet metal, which serve as a reference for cutting. Generally, the thickness of metal sheets varies greatly and can be as thin as a few tenths of a millimeter. Depending on the intended use of the piece, a sheet with the appropriate thickness is used. For the lantern, 2 square pieces are also needed to function as lids. Now, I cut the corners. After cutting the tips of the lids to prevent them from stabbing when carrying the lantern, Juan marks the center of both pieces at once. Let's mark a circumference so that because if not, the candle would go out. One by one, the tinsmith marks and cuts the 35 pieces that make up the lantern. When it comes to fluting cylindrical objects or forming edges, borders or flanges, a special roller, called a flanger, is used. This machine, by changing the working rollers, performs multiple tin plate operations. To tilt the flanges of the lids, the appropriate discs need to be mounted. By means of 2 rollers or small rollers that rotate in opposite directions and press against each other, a more precise and quicker folding of the sheet is achieved, embedding more or less complicated profiles. The top lid needs a hole in the center for the combustion gases to escape. Supporting the tin plate on a lead plate that cushions the blows, Juan cuts small crescents with the punch. It looks nice. Now let's bend this a bit. With hammer blows, the tinsmith bends the fold of the sheets molded by the flanger to 90 degrees. Then, sitting on a bench called a donkey, over a fishtail anvil, he further tightens the angle of the sheet fold. Then, he finishes it with hammer blows on the anvil, which is a flat metal surface. When the tinsmith mass produces the lanterns, he saves a lot of time by changing the discs of the flanger. With the appropriate discs, the folds of the sheets are finished, leaving them completely flat. With the compass, he finds the center of the 2 pieces and drills the insertion hole. He uses the punch to make the holes in all the pieces that need them. Now it's time to curve all the pieces, and for that, Juan mounts the appropriate anvil on the donkey for this task. One of the curved pieces of the lantern is the hanging ring, and it is shaped on the round part of the anvil. The flat section allows right-angle curves. In all these tasks, a wooden hammer is used to avoid marking the blows. Taking advantage of the metal's ductility, he uses pliers to mark the final angles of the pieces, and then molds them. The fluting on the surface of the anvil helps form the grooves and recesses needed for some pieces. The punch is used to pierce the center of the piece, where the support wire will pass through. Each phase of the work has its tools. One mounts a special anvil on the donkey to shape the channels for the glass panes. Hammering the sheet strips over the grooves, he shapes the reinforcements for the glass edges. In this way, the channels fit perfectly to the edges of the glass. As he covers each edge, he cuts small flaps that allow him to fold the tinplate channel. Once the tinsmith has all the pieces ready, it's time to solder them. For this, he uses pre-prepared tin bars, an easily fusible metal containing 50% lead and 50% tin. We section the... Now I take this board, which has 2 nails already measured to the square. For this soldering operation, the beveled end of the soldering iron must be clean. In this way, by touching the hot tip of the tin rod, the metal adheres to the soldering iron, and it can be transferred and spread at the joints of the metals to be soldered. Well, we have the frame. Now the bottom lid. Now the top lid. Now we have to desolder two parts. And with the same soldering iron, the same heat, we now take the hinge and solder it. It's what makes the door open, like a hinge. Don't take too much because it would go to the other side. Now the other part, the door part, the one that opens and closes, right? It must be removed because otherwise it couldn't be opened. With the soldering iron, remove the solder and clean the tin. To place the hinges and locks, he had to desolder the points on one side of the box and apply the turning and locking pieces, finishing the lantern door. Now, this is the latch, the one that holds the door, and this one to pull it. Once he has the box, Juan mounts all the fastening pieces of the lantern. Some are soldered together, and the assembly is held with a piece of wire. Once all the pieces are assembled, he closes the wire ends so the assembly doesn't come apart. Now let's take the lantern frame. The entire lantern support assembly is also soldered to the box. The work is finished by tinning the 4 feet of the base. Well, this is finished. Well, let's make the cup that goes inside, where the oil and wick go. Since the cup's function is to store the lantern's fuel, there should be no pores in the welds where the liquid could escape. To finish the cup, the small pieces that make it up are soldered together. The male cartridge that must fit with the one soldered to the base of the lantern, the handle to hold it, the support for the cotton wick, where the flame will come out, the safety piece which acts as a stop, so the closure doesn't rotate around the entire cup. I'm going to close the piece now. It's finished. The tin production of oil cans, alcuzas, lanterns, cake molds, milk jugs, liquid measures, and other items generally for domestic use has been widespread throughout the Iberian Peninsula. Today, Juan Galan, in his workshop in Seclavin, continues to make many of these traditional objects.